Have you ever wondered how an oscilloscope works? What it does and how it helps engineers and scientists to make sense of the electronic world around us? Today, we delve into the intricate workings of this fascinating device. An oscilloscope, often fondly referred to as an O-scope, is an essential tool for anyone dabbling in the realm of electronics. It is a device that graphically displays varying signal voltages, typically as a two-dimensional plot, with one or more signals plotted against time. Imagine you're listening to your favorite song and you could see the notes floating around you, not as music sheet, but as waves, each crest and trough representing the highs and lows of the rhythm. That's what an oscilloscope does for electrical signals. The heart of an oscilloscope is the cathode ray tube, or CRT. It's a complex vacuum tube where electrons are shot towards a phosphorescent screen. These electrons, when hitting the screen, produce tiny spots of light. The journey of the signal begins at the input jack, where it gets amplified. The amplified signal then travels to the vertical deflection plates. These plates, when charged, cause the electron beam to move vertically up or down. A higher voltage on the plates will cause a larger deflection of the beam, and hence, a larger signal on the screen. Simultaneously, a ramp voltage is applied to the horizontal deflection plates. This voltage increases linearly with time, causing the beam to sweep across the screen from left to right. The combination of these vertical and horizontal movements paints a picture of the signal on the screen. It's important to note that the speed of this horizontal sweep is adjustable, allowing you to zoom in on the signal's details or zoom out to see the bigger picture. The oscilloscope also has a time-based circuit, which ensures that the horizontal sweep happens at a constant and adjustable speed. This allows you to measure the time period and frequency of the signals. Now, on to the trigger function. It gives you control over when to start the horizontal sweep. By setting a trigger level, you can start the sweep when the signal crosses a certain voltage. This helps in stabilizing repeating signals and capturing non-repeating ones. So, to summarize, an oscilloscope works by taking in a signal, amplifying it, and then using deflection plates to plot it on a screen. The vertical movement of the plot represents the signal's voltage, and the horizontal movement represents time. The oscilloscope also has a time-based circuit to control the speed of the horizontal sweep, and a trigger function to control when the sweep starts. Output: the oscilloscope is more than just a fancy voltmeter. It's a window into the world of electronics, allowing us to visualize what we would otherwise only guess. It's an indispensable tool for anyone seeking to understand the ebb and flow of electronic signals. So, the next time you find yourself staring at an oscilloscope screen, remember, you're not just looking at squiggly lines. You're watching a symphony of electrons, each dancing to its own rhythm, creating the electronic world as we know it.